Good day, guys. This presentation is about my findings about a research paper. And it is for my SRT521 assignment 2. The article report title is about a machine learning-based phishing attack detection. The increasing prevalence of phishing attacks poses significant cybersecurity threat to both individuals and organizations, necessitating the development of robust and accurate detection systems. Addressing this pressing concern, the research article titled Machine Learning-Based Phishing Attack Detection Using Multiple Datasets explores the effectiveness of various machine learning classifiers in identifying phishing attempts. The study leverages 3 distinct datasets sourced from the Phish-Tank and UCI machine learning repository. Employing the information gain algorithm for feature reduction and selection, the researchers evaluate 6 machine learning classifiers, including NaiveBayes, ANN, DecisionStump, KNN, J48, and RandomForest. The investigation unfolds 2 stages. First, utilizing all features and then employing the selected features by the IG algorithm. The finding not only revealed the classifier's performances across datasets, but also emphasizes the crucial role of feature selection and enhancing detection accuracy. In an era where phishing attacks continues to proliferate, this research continue to contribute valuable insights to the development of advanced and efficient cybersecurity measure. The purpose of the research. Let's start with a brief overview of phishing attacks. I think I mentioned that already, that the dataset came from multiple repositories, and it's about phishing. And as you know, phishing is in our daily lives. I'm sure you have seen, if not some or many, went into your email inboxes and into your phone SMS messages. For example, an email from seems to be legit sender, right? Send you an email and pretending to be a legit email. Those one of those phishing emails, and also those SMS messages that we receive from our phone, asking us to log in and click, and then you can sign into our bank, pretending to be our real bank, but it's not. Those are kind of phishing. And it's kind of a deception and social engineering attack vector, where the attacker pretend to be the legit sender of an email and somehow convince the recipient to click the link. That's the social engineering there. Somehow the recipient will be lured into knowing that the email is legit, and that's kind of a deception technology. And then what happened after that? After clicking the link, something happened in the background. A file could be downloaded, malware could installed, and most of the time the recipient do not know what's happening in the background. Let's move on to increasing threat to individuals. So it is, and I don't need to pull the many news today about what happened to this, but I'm going to show you shortly a graphs about increasing threats to us as individuals and to organization. So let's go to the importance of accurate phishing detection. Basically, the researcher thinking, okay, this is a growing concern, so we must do a research how to improve our capability to detect this phishing activities. So in totality, the research aims to address the growing threat of phishing attacks by developing an accurate phishing detection system. The authors use 3 datasets gathered from Phish-Tank and UCI machine learning repository, as I mentioned, to train and test machine learning classifiers. The primary research purpose is how to enhance the detection of phishing attacks using machine learning techniques. I think from our class, we discussed NaiveBayes and DecisionStump and J48 and RandomForest. I think I heard a little bit of KNN classifiers, but those are the things that we learned from our class. Okay, here are how they did it. The solution approach. Let's discuss overview of the proposed approach, utilization of multiple datasets, information gain algorithm, evaluation of 6 machine learning classifiers, and 2-stage testing for features versus selected features. So the author employs the information gain IG algorithm for feature reduction and selection. Shortly, I'm going to show you a graph to explain further. And so there are 6 machine learning classifiers. NaiveBayes, ANN, DecisionStump, KNN, J48, RandomForest are evaluated in 2 stages. The first using all features, and the second using features selected by IG algorithms. The classifiers are trained and tested individually on 3 datasets, and their performance is assessed based on accuracy and true-positive rate, precision, recall, and F measure. As I mentioned, there are 3 datasets being one at a time. The input will go through these steps to test and train the use machine learning classifiers. All right. And then it will go to the trained model and then the detection model, and it's going to output as the benign and the anomaly, which is the phishing messages. Dataset 1 is a dataset of phishing website and was gathered between January and May of 2015 and 2017. And the dataset has 48 different features that could be used for classification purpose. It has a binary label 0 and 1, where 0 indicates legitimate website and 1 indicates the phishing website. Dataset 3 contains 9 different features and 1,353 instances. 702 of them belong to phishing website, and 548 belong to legitimate website, and 103 belong to suspicious website. It is similar to dataset 2. This dataset includes 3 labels: 0 for suspicious website, 1 for legitimate website, and -1 for phishing websites. Dataset 2 consists of 11,055 different instances, where 4,898 of them are phishing websites, and 6,157 were legitimate websites. And the same thing as label 0 and 1, and -1 represents suspicious. All right. So there are 30 different features too about this dataset. The information gain algorithm has been used to evaluate the features importance and reduce the number of features in the 3 datasets. All right, as you can see over here, where H represent the entropy and the class, whether it's legitimate, suspicious, or phishing websites. And the attributes denotes the features. So table 1 represents how the IG algorithm picks the features in each dataset. Dataset 1, these are what it picks, and dataset 2, this is what it picks, and dataset 3, these are what it picks. It's basically it's selected features covering 87% of the total weight of each dataset features. So we only see here 87%, most of the features in each dataset. All right, the IG algorithm actually ranked the results as shows in the feature with the high ranks over here, and obviously these are the most ranked score by the IG algorithm to this side, and these will be selected 87% from this side, and other lowest rank will be omitted. And this is for the dataset 2, as you can see over here. Just showing how the IG algorithm picks and ranks the selection features, as we see over here already on our table earlier. And this is for the dataset 3. And so let me just recap again that the first experiment is based on using all features in the datasets, while the second experiment is after feature selection and reduction. All right. As you can see on table 2, RandomForest has the best accuracy with 98.45%, and J48 having the second place with 97.35%. But the DecisionStump rating 77.75%, which is the lowest accuracy. Table 3 is for the dataset 2. Once again, RandomForest classifier with 97.15% accuracy has shown the best result in terms of accuracy, while ANN and KNN classifiers have shown the same accuracy with 96.69%, but with higher precision of 97.8% of ANN. On the other hand, DecisionStump classifier has shown the lowest accuracy among other classifiers. Moving on to dataset 3. And table 4, J48 has shown the superior performance in terms of accuracy with 89.66%. Right? And while ANN and RandomForest classifier shown 88.92% of accuracy for both of them. But in terms of precision, RandomForest classifier was better than ANN classifier with 91.2%. So I'm just going to recap again. The table 2, 3, 4 that we've seen is the first experiment based on using all features in the dataset. So starting from table 5, we'll start again. And this second experiment is feature selection and reduction, right? Just like what we've seen in this table here. I'm just going to show you. Yeah, these are the reducted features. So this is the second experiment that we will perform now. And this is starting from this one, table 5. Oops. All right, table 5. And dataset 1 using feature selection and reduction, right? Reduce features over here. So obviously, RandomForest classifier has the best performance with the accuracy of 98% among other classifier, while DecisionStump classifier has the lowest accuracy with 77.75%. ANN, KNN, and J48 classifiers have shown good performance in terms of accuracy with 95.75, 95.9, and 96.95% respectively. Moving on to dataset 2 using table 6. Almost all classifiers except DecisionStump classifier have shown a good performance with close result, while the RandomForest again made its 93.66 accuracy. On the other hand, DecisionStump classifier has shown the lowest performance among the other classifier with an accuracy of 98%. Moving on to dataset 3, table 7, ANN and RandomForest classifier have shown the best performance here. Yeah, having 88.92 and 88.56% respectively. However, ANN has the superior ANN, as you can see here, 88.92, and the DecisionStump classifier has shown the lowest performance with at 82.65% accuracy. Moving on to additional suggestion. To further improve solution, one might consider exploring ensemble methods that combine multiple classifiers to enhance overall detection accuracy. But mindful about that, we have done that in our labs assignments. By doing that, it uses a huge amount of resources. So it's like we have to make sure we have enough hardware. I meant like memory and processing capability when we do this thing, right? We combine more and more classifier. It consumes a lot of resources, memory wise and processor. Otherwise, when you have slow processor, it will take longer. Yeah, and you have it's time consuming, right? Additionally, incorporate real-time analysis and dynamic features updating could strengthen the system resilience against evolving phishing techniques, like endpoints analysis system, right? That could improve phishing attacks prevention, so to speak. Okay, so let's move on to interesting findings or topics for further exploration, right? The research reveals that RandomForest consistently outperforms other classifiers, especially after feature selection. Further exploration could focus on refining the feature selection process or investigating the adaptability of proposed system to new and any unseen phishing tactics, like the attackers also evolve. They pivot from one way to another. In that case, a new system, detection system, need to be improvised or improved. we can tap on these things by looking at statistics on phishing attacks, which one we will divert our techniques and methodology, which industries are being targeted, right? Like now we can hear a lot of hospitals being targeted by ransomwares. I mentioned ransomwares, but actually the phishing has the part of having that ransomware get into their system. Somehow the attacker, the attacker pretend to be legit and sender pretending to be legit sender and made the recipient download file or click the link, and that's when their hard drive become decrypted, and then it became a ransomware attack, right? The phishing websites characteristics, so there are a lot of websites there. Just when you go there and you click something, it actually you will get phished eventually, right? Those are like deception websites. But also further exploration may have implication and cybersecurity policies and practices like privacy concerns and how to study and consider the information being gathered, so to speak. Finally, let's move on to the overall conclusion. The study's effectiveness addresses the research question by demonstrating the efficacy of machine learning classifiers in detecting phishing attacks. The RandomForest classifier, in particular, is standout for its superior performance. Feature reduction using the IG algorithm provides beneficial and optimizing detection accuracy. The findings underscore the urgency of implementing robust phishing detection system in the face of escalating threats. And with that, I thank you very much for listening to my presentation, and I hope to see you again next time. Have a nice day.